Hello students, welcome back to my channel CGAT Maths. Myself Dr. Suresh Brother. In this video, we are going to discuss linear differential equations of higher order or simply linear differential equation. Here linear in the sense it is first degree. Linear means first degree differential equation of higher orders. Order is not 1, it is second order and higher order differential equation d square y by dx square or d cube y divided by dx cube and so on. Students, in the previous classes, we know that how to solve first order first degree and first order higher degree, and here we are discussing it is higher order first degree differential equation. Here the general solution of higher order first degree differential equation in the form of explicit notation, that is y in terms of x. The linear differential equation of higher order are categorized into two types. One is homogeneous linear differential equation, and another one is non-homogeneous linear differential equation. The example for homogeneous and non-homogeneous is y double dash. Y double dash means d square y by dx square plus y is equal to 0, means the RHS is equal to 0. In non-homogeneous, y double dash plus y is equal to right side containing some exponential functions, or it may contain trigonometric functions, or it may contain polynomial, or any other form, is called non-homogeneous linear differential equation. The standard form is, we are writing, this is in the form of f of d, function of d into y is equal to 0. This is function of d into y is equal to, right side is phi of x. This is non-homogeneous, this is homogeneous PDE. So how this function of d obtained? It is very simple. Students, we know that y double dash means d square y by dx square plus y is equal to 0. We substitute d square by dx square is equal to capital D square. So the given equation becomes d square y plus y is equal to 0. So in these two, you can take y common in the right side. You will get d square plus 1 into y is equal to 0. Here d square plus 1 we call it as function of d. Function of d means each term containing d. Here d square is again containing d. Again here 1 means 1 is also function of d. So how it is? 1 can be written as, it is d raised to 0. So therefore it is function of d into y is equal to 0. Similarly, this is also function of d into y is equal to phi of x. Okay. Now let us discuss the general solution. The general solution of homogeneous LDE, linear differential equation, and the general solution of non-homogeneous linear differential equation containing only the homogeneous linear differential equation containing only complementary function CF. The non-homogeneous general solution of non-homogeneous differential equation containing complementary function and particular integral. Students, now you are going to discuss how to find out complementary function of a homogeneous linear differential equation as well as non-homogeneous linear differential equation. Let us take an example to understand this. So simply you can take as usual y double dash plus y is equal to 0. As we know that you can express in the form of f of d into y is equal to 0, that is in standard form. So in the previous slide we already expressed in the form of function of d, that is d square plus 1 into y is equal to 0. Students, now this is function of d into y is equal to 0. Now we are writing the auxiliary equation of this equation, that is obtained by replacing d by m and neglecting y is equal to 0. Now look at, this is m square plus 1. m square plus 1 is, this is a quadratic equation, students. Quadratic equation. So quadratic equation has two roots. Okay. So here in general here we have taken particular example. In generally means if I write in this form, second order means d square y divided by dx square plus some a1 times of a1 is a constant into dy by dx plus a2 into y is equal to 0 is a second order homogeneous differential equation. This can be written in the form of function of d as d square plus a1 d plus a2 into y is equal to 0 by substitution of d square by dx square is capital D square into y taken right side. Okay, so in generally this is a standard form of second order differential equation. So what is the auxiliary equation here? Auxiliary equation is m square plus a1m plus a2 equal to 0. Students, you can observe here we have taken a particular example. Okay, this is a particular example. This is in general. Since it is a quadratic equation, what are the nature of roots of quadratic equation? Nature of roots of quadratic equation are roots may be different. Roots may be different. Roots there are three types of nature of roots. We will call it as a what? Nature. Nature of roots of quadratic equation. So based on the roots, we are going to write the complementary function, that is CF. In this case, students, m square plus 1. m square plus 1 equal to 0. How to solve this equation? M square equal to minus 1. M equal to plus or minus square root of minus 1. Square root of minus 1 is imaginary quantity, that is m is equal to plus or minus I. So this is a complex number. Complex numbers are always appear in conjugate pairs. So with respect to this, what is the complementary function YC? yc is a dependent. Y is a dependent variable. As I told you already, for the second order and higher order differential equation, the solution is always in terms of explicit form. Y is equal to, in case of plus or minus I, we write C1 cos x plus C2 sin x. I will tell you, so you people, you don't know about this. So in the next slide, based on the roots, I am going to write the complementary function. Okay. Fine. Now, here I am writing the roots. Here I am writing the complementary function. With respect to the, just now we have observed, with respect to a complex number, in generally the complex roots are always appear in conjugate pairs. P is a real part, Q is an imaginary part. In such a case, complementary function is yc is equal to, this is e power real part p into independent variable x into c1 cos imaginary quantity qx plus c2 sin qx. Okay, so this is in generally. So you can take for 2 plus or minus 3i. For 2 plus or minus 3i, yc becomes e raised to real part is 2x into c1 cos 3x plus c2 sin 3x. Remember students, since we are discussing second order, here you have two constant c1 and c2. Similarly for different roots, for example, roots are 1, 2, 3. Just you can consider only roots are 192. Okay. For with respect to roots 192, we write complementary function yc as c1 e power first root, that is 1 into x, plus c2 e power second root is 2 into x. For three roots, that is, let us take minus 1, minus 2, minus 3. What is yc means? C1 e power minus 1 into x plus C2 e power minus 2 into x plus C3 e power minus 3 into x. So, for you will get 4 different roots. You can add one more C4 e power that root into x. For a repeated roots, same roots or equal roots. For example, roots are 3 and 3. The roots of a quadratic equation are 3 and 3. Then yc is c1 plus c2x into e power, we are writing repeated. This is 3 into x. Okay. Similarly, the roots repeated thrice, 3, 3, 3. Then we write yc is equal to c1 plus square into e power 3x. So similarly, for 4 roots, we write c1 plus c2x plus c3x square plus c4x cube into e raised to 3x. So this is, you have to remember, for complex roots, different roots and repeated roots. Okay. Sometimes in case of purely imaginary, for example, you may have plus or minus 3i. You may have plus or minus 3i. In such cases, the real part is 0. The real part is 0 means 2 is 0. Therefore, e raised to 0 into x is just 1. So we write only c1 cos 3x plus c2 sin 3x. Now, Now we discuss the case in such a way that you may have one different root and other two are same roots. So in such a case, what is YC? YC is for a different root, we write C1 e raised to x, that is 1 into x, plus for repeated roots, we start with C2 plus C3x into e raised to 2x. Students, you can also write in the reverse order, that is YC can also be written as C1 plus C2x into e raised to 2x for repeated roots plus C3 into e raised to x for single root. Okay, next, you may have two equal roots, that is 2, 2 and 3, 3. In such a case, what is YC is for two equal roots. For one pair is we write C1 plus C2. C1 plus C2x into e raised to 2x plus next pair is C3 plus C4x into e power 3x. Fine. So next, in case if there is a single different root, that is -1, and another is a complex number, that is 1 plus or minus 2i. In such a case, what is YC? So YC is for a different root, we will write C1 e power minus x plus for 1 plus or minus 2i, real part is p is 1 and q is 2. Just substitute in this, okay, by changing the constant. E power 1 into x into C2 cos 2x plus C3 sin 3x. Hope you understand. So, and last case, you must remember that if there is a complex root repeated twice, that is, for example, you may have 3 plus or minus 4i and 3 plus or minus 4i. So 3 plus or minus 4i repeated twice. In such a case, what is YC? So in such a case, the value of YC is, that is e power p. P means 3. 3 into x into C1 plus C2x into cos 4x plus C3 plus C4x into sin 4x. If it is repeated thrice means you had one more, that is C3x square into cos 4x. Now it start with the C4 plus C5x plus C6x square into sin 4x. Okay, in this way we are going to write the complementary function for homogeneous or non-homogeneous linear differential equation. Thank you so much for watching. We'll meet in the next video to understand how to find out the complementary, that is particular integral of a non-homogeneous linear differential equation. Thank you so much for watching. Thank you.